Good afternoon, everyone. Welcome back to another episode of Dojo Live. Today is Tuesday, November 16th, 2021. I'm Tulio Siragusa, broadcasting from Southern California. And joining me today is Carlos Ponce in Cuernavaca, Mexico. Hi, Carlos. Welcome back.
Pleasure to be here, Tulio.
So we have a great show today. We have two guests with the same company. We have Gavin Cohen, who's the VP of Product, and Ajay Singh, who is the founder and CEO at Zebrium. Welcome to the show, guys. We're looking forward to speaking with you.
Hey, thanks for having us on.
Having us.
Pleasure. So before we get to the topic at hand and get to know all that we can learn and unpack today, why don't we start and getting to know you guys a little bit? If you could kindly introduce yourself, tell the audience who you are. Let's start with AJ. Please give us a little bit about yourself. Thank you for joining us.
Sure. Hey, thanks, Tulio. So I was originally an engineer coming out of school and college. I've always been attracted to deep technology. I was an electrical engineer, worked in disk drive companies for many years, systems companies, but it wasn't just working on cool technology. I've always been attracted to organizations that build solutions for real world user problems, something that I can see, and I can see a customer use our technology and then actually have their life be better in some way. So my entire career has been in companies where I've had the fortune of working on really cool, really deep technology, but also had a chance to see how it solves a real problem for users. So from very low level components all the way to systems, and now applying machine learning to solve problems for our customers.
All right, AJ. So you said you were an engineer, but you're still an engineer. You went from engineering products to engineering solutions, right?
Yeah, that's
Welcome
right.
to the show. Welcome to the
Thank
show. How about you, Gavin? Give us a little bit about yourself, please.
Sure. Well, again, thank you for having us on the show. I'm actually an Australian, which is where my funny accent comes from. So hopefully you guys can understand me. I grew up in Australia and moved to the US in 2014. I also, by training, am a software engineer. So I studied computer science and spent only a few years of my career as a programmer, and then switched over, I guess, to the darker side of the business and product management and marketing side, which is where I fall in today. It's actually the third company I've been at with Ajay, not always by design. We stumbled upon each other, I think, the second time, and then I moved to Zebrium knowing that Ajay was going to be the CEO, and really a pleasure to be on the podcast today. So thank you for having us.
Great to have you. It's only funny to those outside of Australia, right?
That's right.
Yeah.
We have a unique sense of humor.
So we like to have fun. We always say this is a very serious show by not so serious people. So let's talk about Zebrium. What is Zebrium all about? What gave birth to this idea, and what are you guys solving in the marketplace? Why do you exist?
Yeah, so the genesis of the idea was actually a co-founder of ours who's not on today's podcast. He's our CTO, Larry Lancaster. He and our third co-founder, our head of engineering, Rod Bagg, have been deeply immersed in the monitoring and troubleshooting space for about 20 years, actually maybe even longer. So they've always worked on cutting edge predictive monitoring systems. The idea that you could proactively be collecting streams of alerts or metrics from customer-facing applications or systems, and quickly detect when something goes wrong and quickly root cause why it went wrong, so that you can prevent disruptions and downtime and so forth for your customers. So they either worked on or actually architected systems like that for some really good, well-known companies, including NetApp and Data Domain and IBM. And the last company we all got to work together at, Nimble Storage, went from a tiny startup to a public company and $500 million in revenue. And again, they built this cutting-edge system that could proactively detect that something went wrong and also tell the customer what to do to avoid real pain. The problem with those approaches were they were all built with a lot of brute force human effort. Human beings crafting alert rules, writing health checks, matching signatures of a known problem, and building rules saying, if it matches these signatures, then it must be this problem. Here's what you need to do about it. And our CTO, Larry, had the foresight a few years ago to recognize that approach is fine for a world where your software stack is relatively simple, 2 or 3 layers, a web layer, middleware, infrastructure. And also the rate of change is relatively slow. Maybe you do a quarterly software release or maybe a monthly software release. So you can keep up with teams of humans maintaining rules to catch problems. But he saw where the world was going, which was moving towards distributed applications based on containers, Kubernetes, much more complex architectures, many more ways to fail, and also moving to a world where software gets changed, no longer on a monthly cadence, if not even weekly. We have customers that do multiple pull requests and deployments a day. In this kind of world where it's no longer a simple stack, it's dozens of interconnected microservices and many things can break. And any set of rules you build today will be obsolete in 3 months. His idea was that humans building rules will no longer work. So you need machine learning based systems that can learn the application and tell you when something's going wrong, and even better, tell you what's going wrong. So he read all the academic research in the space, built lots of prototypes to figure out how we could do it better than the simplistic approach that people still do. And once we got to the point he had a working prototype based on logs, that's when we went the traditional Silicon Valley route, raised venture funding, turned that prototype and that concept into a product, and then started testing it, very early from alpha to beta. It turns out to be a very deep technology stack we had to build to solve an end user's problem quickly. And it's taken us over a couple of years to do that. But the end result has been well worth the journey. So that's sort of the history of Zebrium. Deep knowledge of a particular space and how people deal with it, recognition that we would have to do something different to deal with the way the world was going, and then the brains to be able to convert that concept into a working product.
Excellent. All right, let's unpack the more. Carlos, let's introduce the topic and dig right in today.
Absolutely. Thank you, Tulio. And thanks, of course, our guests for being here with us today. The topic as chosen by our guests is Troubleshoot faster. Why machine learning is a game changer for RCA using logs. So the first question that I have for you, Gavin and AJ, is why did you choose this particular topic, and why did you feel it was relevant for today's day and age? Let's start there. Thank you.
Well, we picked it because we tried to get as many jargon words as possible into one sentence. I think we achieved a really good showing there. But really, this describes.
I'm sorry, I have to say this. You're aging yourself when you look at RCA and think of RCA jacks.
That's maybe the record company.
But the millennials like, what is that?
Yeah, that's right.
Right.
So it's not that, believe it or not.
It's not that,
but it speaks to the problem that we solve, and Ajay alluded to it earlier. But there's a real problem with today's applications, and that is they're big and they're complex and they're dynamic and they're live all the time, and there are lots of users that get impacted when things go wrong, and they fail in very, very complicated ways. When they fail, and you hear about this periodically when Facebook goes down for even 2 minutes, half the world notices, it's really, really hard to figure out what went wrong. And what happens typically at the back end is when something fails, beyond the obvious things that are known, someone has to go digging through software logs. That's this idea of RCA, root cause analysis. So some person, some human, has to hunt through those logs and kind of trace through and figure out what happens. And that's easy when you have small volumes of logs and you know what you're looking for. And it's really, really difficult when you have millions or billions of log lines coming in from thousands of different services, and you don't know what to look for. So what ends up happening is engineers go hunting based on their instincts, and they typically look for things that are unexpected, events that shouldn't be there, or rare events, and so on. And they also look for errors, the usual things that you might search on. And it's kind of this cat and mouse game where you chase through the logs and you look for some clue in there, and based on what you see, you go looking somewhere else. And it can take minutes or hours or days to track it down, but that's what humans do. So the notion of what we did and why we picked the topic is because that's what our platform does. Instead of having humans search through these logs, it leverages machine learning, and it does what an expert human would do, although it's not an expert. It learns as it goes. It's unsupervised, and it literally can do that log analysis for you almost instantly and come back and tell you what that root cause is.
Now,
Thank you so much. Thank you so much, Gavin.
taking the mean time to resolve an issue to almost zero is a pretty big statement. How's that possible? I mean, we just talked about how it's done now, right? You need an army of people to analyze this information and come up with rules. And every time there's another nuance, there's another rule. And in managing the rules, it's a job in itself. So it's not something that gets resolved instantly today. I mean, you just mentioned Facebook has a 2-minute downtime. Everybody knows about it. I don't think everybody knows why there was a half-a-day downtime just a few weeks ago. So we still want to know what happened. But Facebook, if you're watching, we want to know. So how does this enable to the possibility of getting to a mean time resolution to almost zero?
Yeah, and that's a really good question. And can you, maybe even another question, can you make it zero? And so what happens is the traditional technique is human driven. So it's certainly nowhere near zero, and it's typically measured in hours, right? Maybe minutes if you get lucky. And what we can do is almost in real time. So our technology lags by seconds, maybe up to a minute. It's analyzing these logs, and it's picking out the patterns that it believes are problems, and it's surfacing them so that someone can see them. So what happens is, if there's a problem, if there's one of these outages or problems, the first thing to do is not to go searching and hunting. It's look at the Zebrium dashboard or look at the alerts thrown by Zebrium, and that will basically tell you what happened. And as quickly as you can look at a small report, 10 lines of report, you can then go ahead and resolve and bring up the application again. So it's typically not zero. It's moving to a very small number of minutes or seconds that it would take to resolve using our technology. However, there's something really cool that we do, which is that the first time a problem happens, obviously, it's just the machine learning base using its own magicness to figure out what happens. But when it does that, it generates a fingerprint. And the fingerprint basically is the sort of the patterns and a proxy for what was in the logs that caused this to happen. And it remembers that fingerprint, and you can actually assign a run book to that fingerprint using other tools. So now what happens is, let's say that same problem happens again next week or next month or next year. You don't even have to have a human inspect the report that we generate. You can actually have us trigger the resolution. And in that sense, you literally could take that MTTR all the way down to zero by just recognizing things either as they happen or before they impact users, and then resolving them through automation without having humans involved.
Gavin, I got a quick question here. Many of our viewers might not have a deep engineering or technical background, myself included, because I'm not an engineer. So to these viewers, if you don't mind explaining just in a few words, or in layman's terms, I always say, what exactly is mean time to resolve? Can you elaborate on this concept, please?
Yeah, so it's a measurement of when you detect something. So you your users start calling in to say Facebook's down or whatever, or your big monitoring dashboard detects something, to how long that incident or that problem is actually fixed. And mean time to resolve actually can mean something slightly different. Often the resolution isn't actually fixing the problem, it's working around the problem. And you hear this all the time. My PC is hung. You don't resolve that issue, you reboot your PC and it comes back again and it works for another week. That sort of, when people talk about MTTR, it might be, it was the time taken between when it hung and when they rebooted and things came back. That's actually not resolving the problem. That's working around it. And in the true sense, when you talk about software incidents and what our technology is trying to do, we're actually trying to go beyond a workaround. We're actually trying to pinpoint the root cause so you can genuinely resolve it. But in essence, it's really just the amount of time it took to fix the issue and have users back on the platform.
Oh, I see. Okay, well, I appreciate it, Gavin. Back to you, Tulio.
Yeah, I'm enjoying this. It reminds me of the start of my career 32 years ago. I started at a knock center at night. So meantime to repair or resolve was everything, right? All the metrics were around that time. And I secretly enjoyed waking up senior executives at 3 a.m. in the morning to escalate issues when things took too long. I'm curious about this idea of coming to almost zero time. It reminds me of Six Sigma. Right? A lot of organizations who adopt Six Sigma try to get to this problem resolution down to 0.6, whatever that percentage is. I think that was the number. And you've got black belts that live and die by this. Is this sort of a little bit of a codification around that concept that you've created?
I worked for a manufacturing company long ago, so I do remember Six Sigma techniques to try and wring out, any inefficiencies in the production system. I guess if you abstract it to a high enough level, there's some similarities, which is you're trying to find the real outliers and bring them to the attention of the human. Of course, the world is very different. In a manufacturing world, there's some stability. You establish a manufacturing process, and then it'll stay there for months or years, and you're just trying to wring out the bugs or the edges, the errors on the edges. In today's software world, change is constant. And that's what makes the problem harder. There is no normal anymore. So every day brings a new set of features. The user behavior is changing. You're adding new users, perhaps, and then on top of this shifting baseline, you're experiencing bugs or performance issues or weird errors for the users. So if you abstract it enough, there's some similarities. But when you get down to it, finding outliers for an ever-changing software baseline is a trickier problem, and you really don't have the resources to throw tens of, in those days it was statistics experts or process experts. Today, the equivalent might be data scientists. You can't afford to throw enough data scientists at the problem because you're going to have this never-ending stream of outliers every week. So this is where you need to replace that human instinct and intelligence with something more scalable, such as machine learning.
Yeah, it's interesting. What prompted that? This was a software engineering company that we landed a deal with GE, and GE is a huge, at least at the time, was a huge Six Sigma shop, and we adopted Six Sigma in software engineering, which was very, very difficult. As you said, there were a lot of moving pieces. So I'm curious about the ecosystem, where this fits in, who the client is in terms of adopting this product. Is it a help desk type solution that you're selling into? Is it at the engineering level and how things are structured from the beginning? Who is your client and why?
I was just going to jump in quickly and say that I think there are two kind of key use cases and types of customers. One is, and we talk about it, again, using our technical jargon, the streaming use case. And that is, it's the people running live environments, SaaS applications and, applications that actually are always running. And in those worlds, the logs just come streaming into us. And what we do is we pick out the problems and we give them the root cause when there is a problem automatically. that kind of customer tends to be this sort of new age environment. It's the equivalent of the old knock. Today it's called DevOps, and the SREs are the people that monitor and orchestrate and are responsible for keeping that environment running. So in that sense, that's our customer. It's that team. They buy it, they rely on it, and they use it to save hours and hours of downtime and troubleshooting time when there's an incident. So that's one sort of big group of users. The other one is pretty interesting. It's more of the traditional technical support group. And I'll use an example. We're engaged with a very large Fortune 100 company that has thousands and thousands of support engineers. And when there are problems, because their products are deployed at customer environments, they, at some point when they can't solve the problem over the phone or via email, they ask their customers to send in a bundle of logs. And that's what the customers do. There's like a button on some of their products that's, upload bundle of logs to support. And traditionally, these support teams of thousands of people had escalation engineers who spent their whole life opening these support logs and going through them painstakingly for hours to figure out the root cause. Now what they do is they pull these in and they play it through our platform, and we pop up that root cause in seconds or minutes and give them the answer. So that's a whole sort of space as well. And in that case, our customer is a tech company that has a big technical support center that deals with complex troubleshooting.
Brilliant. So let's just paint the picture a little bit about the value of this. I was thinking many organizations who run mission critical application, they'll demand SLAs with their technology partners. And some of those SLAs have penalties if you don't maintain the timeline to resolve issues. Huge penalties in some cases. So it's a huge risk for technology partners to provide that kind of service to these mission critical organizations. Does this solve or ease the challenge of meeting SLAs for technology partners?
Yeah, I mean, very, very much so. And actually, some of our customers are actually service providers that have exactly that, and their justification of Zebrium is all around the costs of downtime and the SLAs. So they use us to troubleshoot the environments that they are responsible for and they manage. So yeah, very, very much. And that falls much more into that sort of live streaming example. It's like someone responsible for keeping an application running would have us be in the background monitoring those logs and then popping up the information when there's a problem that they can root cause it very quickly.
So with this, you could essentially find the root cause of a problem before the client even reports that there's a problem.
Yeah, very much so.
Really?
And there are many examples of how this happens in real life, because often, the problem that the customer notices has been lurking there for some amount of time. The system's been getting slower and slower and slower, and no one's reported it, and no one really knows where the problem is. The client might think it's just their web browser that's slowed down or their PC. We can spot those pattern changes in the logs and proactively alert someone to their presence and prevent that from happening. So that's certainly something that we've done many times with our customers.
Yeah, I mean, a very crude analogy might be in a physical world, you can start to spot signs of rust or termites before the building collapses. I translate that into the software world. Much of observability and monitoring is built around user-facing symptoms, which means the problems are already bad enough that they are visible or likely to be visible to the customer. So our approach actually starts to catch the leading edges of the problem. You start to get these weird warnings or error messages, and often in software, problems start small and then they propagate, and you have sometimes many hours before it gets bad enough that'll trip over or cause a big slowdown or completely crash. And that's what we can do. We can actually get a leading edge of the problem.
AJ
Nice.
and Gavin, a couple of things. We're approaching the final segment of today's conversation, so I wouldn't want to end it without asking you specifically about Zebrium. The reason is because many of our viewers out there are engineers or people who might want to approach the company, maybe come work for you, who knows. So what would you say to them in regards to what makes Zebrium an awesome company to work for? What is your company culture like that would help you reel in the best of talent out there?
Yeah, no, that's a great question. So we don't have, I've been at big companies where you print out your values on little cards and you hand them out to all the employees.
Right.
Yeah, we're not yet big enough to have done that, but nevertheless, there's always an implicit culture that emerges.
Right.
And I guess if I had to pick out some of the attributes, and I'll be curious to see what Gavin says, it's basically being, very open. So the culture of the team is we are very open with each other when things are good and when things are bad. We don't want, people who are difficult to work with. If you're very smart but are challenging to work with, in our experience, and I know there's different ways to build a company. The way we've generally been lucky to work in companies where people have some basic social skills of how to deal with their colleagues and their partners. If you can't do that, you probably won't be a good fit here. The third thing sort of started by accident, and COVID actually made it very clear, because we haven't been in the office for almost 2 years now, and that is that we trust employees. So we hire people who know their jobs. We give them a direction. We expect them to communicate when things aren't going well or they need inputs. But our team is entirely remote. We're not in any one city or one geography. We obviously don't meet each other face to face very often anymore. And it's working extremely well because everyone, sort of fits that culture. I sort of know my job. If I don't know, I'll ask, and I'm going to just execute. And the modern tool sets like Zoom and Slack and a whole bunch of other things that every software company uses now make that part of the culture so much easier to sustain. If you'd asked me 5 years ago, could I see myself working in a company that's fully remote, I would have been very dubious, because I always thought hard discussions, you need to be in a room in front of a whiteboard. And without that, you lose something. And what we've learned is if the people, they're self-motivated, self-driven, they like to be empowered, they like to be trusted, actually they fit this kind of culture extremely well.
Awesome. Incredible.
Nice.
Thank you so much.
I still prefer to be in a room with a whiteboard, but that's just
you keep dating yourself there, RCA.
Yes, exactly. I mean, there's to me, there's nothing like it sitting there and collaborating to do that. But you could do that with virtual whiteboards today. So it's been great to have you both on the show. We've learned a lot. It seems as though any technology partner to at least mission critical application clients should have this. Like, you want to get to a root cause of a problem and potentially even avoid having someone call in with a problem, get ahead of it. You need tools like this. So we congratulate you and we wish you a lot of success, and hope to hear more use cases in the future from you. Stay with us as we go off the air in just a minute. For wrap up, Carlos, what do we got coming up for the rest of the week?
Of course, Julio, we have 2 more shows for the rest of the week. One tomorrow with Jeremy Almond, the founder and CEO of Paystand, which is a platform for payments, for online payments, for B2B payments. And then we have on Thursday, we're going to be speaking with Rohin Parkar, the co-founder and CEO of Spintly. The topic will be wireless mesh, the future of building automation. That's what we have right here on Dojo Live. So everyone, don't miss them. Join us right here at 12 p.m. Pacific, Wednesday and Thursday. And remember, have fun, enjoy life, and be safe. Thank you.
See you soon.